Hi, I'm Kashish and today I'm going to discuss homework 11 question 1 for EL6303. So the question states that we know that x of t is real and its White-Sense stationary. We have to show that its perspectral density is even and positive and that its autocorrelation is real and even. It does although suffice to say that if the autocorrelation is even, the perspectral density is also even, but we're going to prove this. So starting with the B part, that is the perspectral density is real and positive. So what do we mean by real and positive? Basically, it's greater than or equal to 0. So SXX omega should be greater than or equal to 0. So there's a property about the autocorrelation that we know. We know that if we have a constant a that represents a non-negative definite constant, we can say that summation I going from 1 to n, summation j going from 1 to n, ai aj star rxx ti tj is greater than or equal to 0. So this, if we had to put it in words, we would say that rxx t1 t2 is representing a non-negative definitive function. Now we know that that x of t is a White-Sense stationary process. That's why the rxx ti tj can be replaced by rxx ti minus tj, because it's going to be dependent on only the time difference of two time instants. So summation I going from 1 to n, j going from 1 to n, ai aj star rxx ti minus tj. Now, we also know the formula for Rxx and Sxx, and we know that the relationship they share is a Fourier transform or an inverse Fourier transform. So we can write Rxx ti minus tj as summation minus infinity to infinity 1 upon 2 pi Sxx omega e raised to j omega ti minus tj d omega. And this part will come down as it is. Now, what we're going to do is we're going to assume that ai is equal to aj and that they are real positive integers. So, so once you assume ai equal to aj and you assume so once you assume ai equal to aj and you're basically taking into consideration only one time instant, you know that this will become ti square. So minus infinity to infinity, summation I going from 1 to n, ai square into e raised to j omega ti square. So that's going to be whole square into 1 upon 2 pi sxx omega d omega. Now, since this value is a square, it's easy to say that this is greater than or equal to 0 always. Hence, prove that sxx omega is even and positive. Now going to the second part, that says Rxx of tau is real and even. So we know that Rxx t1 t2 can be written as Rxx t1 minus t2 in our case, and that is expected value of t1 into expected value of x of t1 into x of t2. And now what we're going to do is we're going to take into consideration a constant tau and tau equal to t1 minus t2. Now it's easy to see tau equal to t1 minus t2 is basically the time difference. So if you take this as minus tau, you can change the values inside and you're still going to get t2 minus t1, but it's basically just going to be the time difference. Therefore, it's easy to see that this is equal to this, hence minus tau is equal to tau. Therefore, rxx tau is equal to rxx minus tau. Therefore, it's even, and we also know that when t1 is equal to t2 is equal to t, that is basically any value of t1 and t2, we know that rxxt is expected value x squared t, and since it's x squared t, we can say rxxt is greater than or equal to 0, and therefore it's real. So this was the first part of homework 11 problem 1. Thank you.